Now let's take a look at our figure 20-37, also from Stallcup's Electrical Design Book, Volume 2. And notice we're going to make an industrial tap here is what we're going to make. And sizing this overcurrent protection device on this primary side of the transformer, you can start with, say, figure 20-10 in chapter 20 of Stallcup's Electrical Design Book, Volume 2. And sometimes we may have to go up to 250% here due to inrush current, based upon the transformer's design and so forth. Or maybe we just want to increase it to 250% because this secondary side feeds and supplies a lot of fractional horsepower motors that if we size the overcurrent device for the largest and added the remaining fractional horsepower motors to it, we couldn't raise this overcurrent device up based upon the motor calculation, so we could use it and size it, by table 450.3b based upon transformer rules and regulations. So we select the steel here to ground your transformer in the illustration from 250.30A7, item 2, and 250.104D as in dog. But now, if you notice on the secondary side, we're making an industrial tap. So you either put the 125% to size this overcurrent device in the primary side, and if you go above above 125%, up to 250% maybe, you have to put the 125% in this secondary. But if you tap over 10 foot up to 25 foot, is this section allows you to do, this overcurrent device that you see in the panel board in the illustration has to protect the conductors plus the transformer output. So looking at the illustration then and looking at sizing the THWN copper conductors that we're going to select, notice that we apply what's required in 240.21C3 item 2, and the calculated load is 345. Already calculated now. It's already calculated for us. Step 2, 310.10, to supply 345, it takes a 500 kc mill in the 75-degree column in table 310.16, which is 380 amps for that conductor, and it will supply 345. The overcurrent protection device now, we will select it next, but right now we're just selecting in this boxed in information, sizing THWN copper conductors, we're selecting a 500 kc mill THWN copper conductor at 380 amps to supply 345 amps in step 1, and that's what the solution is giving us. Now, sizing the overcurrent device in the next boxed in set of rules, we look at step 1 for calculating the overcurrent device, and 240.4E says yes, that is considered a tap, and you can size your overcurrent device accordingly. And 240.21C3 item 1, as well as 240.4B as in boy, 500 kc mill, good for 380 amp. We can round it down to 350, and it's going to protect the conductor and protect the output of the transformer as required by 240.21C3. And that's basically what the solution is telling us. Use the 350 amps and you will protect the output of the transformer plus the conductors. But if I rounded it up to 400, then it would not protect step 1 or step 2 and sizing the conductors, THWN copper conductors, is illustrated in the boxed in information to the left. And that's what our figure 20-37 is illustrating. And if you wanted to pick up more about these tap rules, transformer secondary conductors, start in Stallcup's Electrical Design Book, Volume 1, and start with figure 9-22, and you will go through a series of numbers of figures that will show you all the tap rules of secondary transformer conductors of 240.21C as in car.